All right, today's question is, are all Etch-a-Sketch reflections isometries? And I'm here to prove that the answer to that question is no. So first, it's important to read some definitions. Again, sorry for the glare, but I'll be reading through them, so that glare really doesn't matter. So the definition of reflection is, given a mirror line, draw a new line that is perpendicular to the mirror line through the point to be reflected. The image is the point on the other side of the mirror line from the original point that is the same distance from the mirror line as the original point is to the mirror line. And then our definition of isometry is a transformation or function that preserves distance. So since we are proving that not all reflections are isometries, we can just do one example versus doing an abstract expression. And so our concrete reflection is going to be y equal 2x. So that is going to be our line. And then our two concrete points are going to be 0, 0, and 0, 5. And it's clear to see, that the distance is 5. And so drawing that over here, we have 0, 0, and 0, 5. And this is our y equals 2x. So what we need to do is we need to find the reflected points and see what their distance is. And so, looking over here, this, like I said, line is y equals 2x. And so this is going to be our perpendicular line, which is y equals -1, 2, x. And then we do have our y-intercept there along this line if you were to just to extend it, which is, we're going to squish here a little, but because that, we know it's 5. So what we need to do is reflect this point across this line and this point across that line. And our 0, 0 point is actually pretty easy because it just kind of reflects onto itself. So we're left to find one more point, which is going to be this one. So to start, it would be extremely helpful to know what this point is. And to do that, all we have to do is match these two equations together. And again, this works because it's showing what this is. These two equations share this one point. And so just doing a little bit of math here, you would times both of the sides by 2. You'd get 4x equals, this would be -x because it cancels out, plus 10. Adding 1x to that side would be 5x equals 10. Dividing both the sides by 5, and you're left with x equals 2. And so we know that this x point will be 2, and we just have to find what y is. And this part is actually easier than what we just did because we can just plug it into this equation to find what y is on this line. So this is the x point, so 2 times 2 is our y, which is 4. So now we know that this point is 2, 4. From here on out, we can just measure. So to get from 0, 5 to 2, 4, you're going down 1 and over 2, giving this a distance of 3. So we need to know, since it's a reflected point and it's the equal distance, we have to do the same on this side. So we're going down 1 and over 2, which is going to end us with 4, 3. As this point here, that's reflected. And again, this is going to be 3, so we know that that actually is it because it is the same distance. So now we know that our reflective point is 4, 3. So now all we have to do is find the distance and see if it's the same distance. So we're going to do absolute value for that to avoid all negatives. And we can see that this equals 7. So the distance between these 2 points would be 7, which is not equal to 5. So it's not an isometry.